Okay, salam Jami'an. Our exercise today is also about limit as yesterday. We are going to solve this exercise, which is number 27 in the book. Excluded number part 7. I wouldn't like to solve this part. Okay. Part 1, we need to calculate a limit as x tends to minus 1 of x squared minus 4x minus 5 over x squared plus 5x plus 4. If you did replace x by minus 1, you will obtain 0 over 0. It's an IF. So you need to find, as we said yesterday, when you got 0 over 0 IF, you have to factorize and simplify. In most of the cases, x tends to minus 1. Let's just use our calculator. So we need to find the roots. We need to find the roots of the numerator. Mod 5, 3. A is 1, B is minus 4, and C is minus 5. And you can find the roots of the numerator using the method A minus B plus C. The roots are 5 and minus 1. So you put A outside, which is 1. X minus 1 into x minus 5. Over the roots of the denominator are minus 1 and minus 4. So it's x minus 1 into x minus 4. You should simplify by x plus 1 and then substitute. Replace x by minus 1. Minus 1 minus 5 minus 6 over minus 1 plus 4 is a 3, and the answer is minus 2. This is part 1. Part 2. Limit as x tends to 1. Someone will ask why you didn't calculate minus 1 minus and minus 1 plus. Because in the result I'm obtaining a constant number. It wouldn't make any difference. If you did calculate minus 1 minus, you will obtain minus 2. If you did calculate minus 1 plus, you will obtain minus 2. Is the same. Part 2. Limit as x tends to 1. Of what? Of x squared minus 3x plus 2 over x squared minus 1. If you did replace by 1, you will obtain 0 over 0 IF. So you have to factorize and simplify. I will factorize the numerator by using its roots. The roots are 1 and 2. So it's x minus 1 into x minus 2 over the denominator. X squared minus 1 is x minus 1, x plus 1, a squared minus b squared. You should simplify by x minus 1. 1 minus 2 minus 1 over 1 plus 1 over 2, and this is the answer. Part 3. I need to find limit as x tends to minus. Limit as x tends to minus of x plus 2 over radical of x squared plus 4x plus 4. X squared plus 4x plus 4. I should replace x by 2. 2 plus 2 is 4 over radical of 4 plus 8, 12 plus 4 radical 16. The answer is 4 over 4, and the answer is 1. This is part 3. Part 4. Limit as x tends to minus 3. Here in this case, you should know if he is asking about minus 3 minus or minus 3 plus, because minus 3 is a root of the denominator, and you should know if it's a 0 plus or a 0 minus in the denominator. So in this case, limit as x tends to 2x plus 1 over x plus 3 plus radical of x plus 4 as x tends to minus 3. So we should calculate at minus 3 minus and at minus 3 plus. When you replace in this fraction x by minus 3, you obtain minus 6 plus 1 minus 5 over minus 3 plus 3 is 0. You should determine if it's a 0 plus or a 0 minus. Of course, if you did, you find this using the sign table of the denominator. You see, you write x plus 3, admits minus 3 as a root, opposite same. So before minus 3 it's a minus, so it's a 0 minus. Plus radical of minus 3 plus 4 radical 1. So minus 5 over 0 minus is plus infinity plus 1 equal plus infinity. As the same, limit as x tends minus 3 plus of this fraction of 2x plus 1 over x plus 3 added to radical of x plus 4, you will obtain minus 5 over 0 plus radical 1 minus 5 over 0 plus minus over plus is minus, minus infinity plus 1 is minus infinity. So this is part 4. Now I'm not going to solve part 5. Now part 6. Limit as x tends 1 plus of x squared minus 1 over radical of x minus 1. If you did replace, substitute x by 1, you will obtain 0 over 0 if. So you should factorize. In this case, you not only need to factorize because you have quadratic binomial and you have also radical. You need to factorize and also you need to multiply by the conjugate. So limit as x tends 1 plus. X squared minus 1 is a squared minus b squared is x minus 1 into x plus 1 over radical of x minus 1. We need to multiply by its conjugate, which is radical of x minus 1, radical of x minus 1. The conjugate of radical a is still radical a. So equal limit as x tends 1 plus x minus 1 into x plus 1 into radical of x minus 1. I am multiplying the numerators over multiplying the denominators. Radical x minus 1 times radical x minus 1 is x minus 1. Now I can simplify by x minus 1, then I substitute x by 1. 1 plus 1 is 2, radical of 1 minus 1, 0. 2 times 0 is 0. Part 8. Limit as x tends to 0, radical of 1 plus x minus radical of 1 minus x over x. If you did substitute x by 0, you will obtain 0 over 0 if. Usually we do factorize, but in the case of radical we can't factorize. You only have to multiply by the conjugate. The conjugate of the numerator, which is radical of 1 plus x minus radical of 1 minus x, is radical of 1 plus x plus radical of 1 minus x over x into radical of 1 plus x plus radical of 1 minus x. I did multiply by the conjugate of the numerator in the numerator and in the denominator. So I do obtain limit as x tends to 0. It's in the form a minus b into a plus b. So it's a square, which cancel the radical, you will obtain 1 plus x, minus b square, which is cancel the radical also, over 1 minus x, over x into radical of 1 plus x plus radical of 1 minus x, equal limit as x tends to 0. 1 minus 1 is 0, x minus minus x is 2x over x into radical of 1 plus x plus radical of 1 minus x. You do simplify by x. Now you can substitute 2 over radical 1 plus radical 1 over 2, and the answer is 1. This was part 8. Okay, maybe you have to redo this exercise by yourself after watching the video, because it's important and it's not that much easy. Now we have to do the part 8. Part 8. No, not, yeah, we did part 8. Now part 9. Limit as x tends to 9, x minus 9 over radical x minus 3. In this case also you will obtain 0 over 0 if you did replace x by 9. So we have to, usually you have to factorize, but in this case you don't factorize because you have radical, so you only multiply by the conjugate. So limit as x tends to 9, x minus 9 over radical x minus 3. The conjugate of the denominator, the conjugate of radical x minus 3 is radical x plus 3 and radical x plus 3. So its limit as x tends to 9, x minus 9 into radical of x plus 3 over radical x minus 3, radical x plus 3 is the form a minus b, a plus b. So it's a square, radical x square is x, minus b square, 3 square is 9. x minus 9 and x minus 9, you do cancel the two factors, you do simplify by the same factor. So limit as x tends to 9, radical of 9 is 3 plus 3, radical of x plus 3, radical of 9 3 plus 3 is 6. You can see as long as I'm having x, I'm writing limit. When I obtain an answer, or when I replace x by its value, by the value that it's tending to, I just don't stop writing limit. But as long as I am having limit, as long I am having x in the expression, I am writing limit. Part 10, this is going to be our last part for today. I will record a video about these two parts and similar cases when x tends to infinity of a radical of an irrational function. Limit as x tends to 0, x over radical x squared plus 4 minus 2. Also it's 0 over 0 if. So I should multiply by its conjugate, by the conjugate of the denominator in this case. Why the conjugate of the denominator? Because I do have radical in the denominator. Of course you have to change the sign of the operation between the two factors. So limit as x tends to 0, a minus b, a plus b, it's a square, radical square, they cancel each other, 2 square is 4. In the numerator x into radical of x square plus 4 plus 2 equal limit as x tends to 0, x into radical of x square plus 4 plus 2 over plus 4 minus 4 x square. You have to simplify by x. So limit as x tends to 0, radical of x square plus 4 plus 2 over x. If I did substitute, I'm obtaining a 0 in the denominator. So he should determine if I should calculate 0 plus, x tends to 0 plus, or x tends to 0 minus. Or I should calculate both of them. I should calculate limit at 0 plus and limit at 0 minus. I will assume that the part is about 0 plus. Okay? 0 plus 4 is 4, radical of 4, 2 plus 2, 4 over 0 plus, and the answer is plus infinity. That's it for today. I will see you in another video tomorrow, inshallah. See you, bye.